Exercise number 1.5 and 1.6 from the chapter Sets. Let's begin. First question we have given, let U or the universal set be 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A be 1, 2, 3, 4, and set B is equals to 2, 4, 6, 8, and set C comprises of 3, 4, 5, and 6. The question is, we have to find first A complement, second B complement, A union C complement, fourth A union D complement, fifth A complement complement, and sixth B minus C complement. Before we begin, let's understand what does a complement mean. The complement is first and foremost denoted by the single apostrophe as such. Now, what is a complement? Let's say there is a set of numbers, and out of those numbers we have taken apart another little set, which is a subset of the whole set. Let's take an example of the same sum. Let's assume that the whole set comprises of 1, 2, 3, 4, 5, 6, 7, 8, 9, and the subset comprises of 1, 2, 3, and 4. In this given scenario, let's assume that this whole box is the universal set U, and this little circle is the set A. Now, the universal set comprises of 1, 2, 3, 4, 5, 6, 7, 8, 9, and A consists of only 1, 2, 3, 4, which is a subset of U. A complement can be understood by simply mathematically calculating U minus A. In simple terms, the complement of a given set is the whole set reduced from the universal set. For instance, in the given scenario, we have A set to be 1, 2, 3, 4, and thus A complement would be everything that is involved in the universal set except A. That means through the Venn diagram we can simply get that this whole of the box, the whole rectangle box except the part of A, this whole rectangle box, I'll change the color. This whole rectangular box where I've shaded with a yellow color is the A complement, which means it is the whole of this universal set except set A. So now let's understand how to solve these questions. As we did right now, we have currently solved the first question, that is the A complement. Let's take a look at the further questions. A complement is none other than universal set minus the A set, which means a complement of a set is everything that is involved, that is comprises of universal set except the set itself. Thus, a set of A, the complement of set B, in other words, the complement of set B will be everything that is in the universal set except set B. So B complement is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the universal set minus 2, 4, 6, 8. 2, 4, 6, 8. So if you remove that, we get 1, 3, 5, 7, and 9. Again, we have the whole universal set. We have the whole universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. We reduce from that the set B, or we minus the set B from it. Thus, we get the remaining set to be 1, 3, 5, 7, 9, which is none other than B complement. Let's take a look at the next question. This one is a different one. We have A union C complement, which means first we have to find what is A union C, and then we have to find the complement of it. So first what we have to do is we have to find A union C, which is none other than A plus C. Let's take a look. Over here we have A set, and over here we have set C. In set A we have 1, 2, 3, 4. And in set C we have 3, 4, 5, and 6. For simplicity, since we don't want to make any mistakes, we'll first write the elements which are common in both, which are 3, 4, 3, 4. 3, 4. And since this is the union we are talking about, we'll write the remaining numbers as well, the remaining elements as well. That is 1, 2, 5, and 6. Thus, this is the union of A and C. This is the union of A and C. 1, 2, 3, 4, 5, and 6. Next, we have to find what is A union C complement. The complement of a set of set A union C would be universal set minus the set A union C. In universal set, we have 1, 2, all the way up to 9, minus we have 1, 2, all the way up to 6. If I reduce this from this, I will get 7, 8, and 9, which is correctly given in the solutions. Let's move along. Question number 4. A union B complement. Now, A union B complement. Before we take a look into that, let's see what was A and B. Now, A, we know that it was a 1, 2, 3, 4, and B is 2, 4, 6, 8. Let's write that down. A is 1, 2, 3, 4, and B is 2, 4, 6, 8. A, I use a pen. A is 1, 2, 3, and 4. B is 2, 4, 6, and 8. Next, now let's solve it. A union B complement. Now the union between A and B, we have 1 2 3 4 and 2 4 6 8. We have a set of numbers that is starting from 1 ending till 4, and even numbers starting from 2 ending till 8. The union of the given set A union B would be 1 2 3 4 6 8. This is none other than A union B. Now, before we start finding the complement of A union B, the formula is universal set minus A union B. Now, A union B. Let's look at the solution. We have 1 2 3 4 6 8 as I rightly solved. Next, we have universal set 1 2 3 4 5 6 7 8 9 minus 1 2 3 4 6 8. So we are left with, if we reduce them all, 1 2 3 4 6 and 8, we are left with 5 7 9, and this is the answer for A union B, the whole complement. Next, we have a complement's complement. Now, when we solve a complement of a set, that is, let's say for example set A, we simply take out the given set of elements from the universal set. Now, if I remove these 4 elements from the universal set, we are left with a complement, that is 5 6 7 8 and 9. Now, if I make a complement of the A complement, that is a complement's complement, in simple words, they cross out each other. But if I want to explain it even more better, I would say universal set minus A complement. Now, if I remove these 5 elements from the universal set, I am again left out with none other than with the A set itself. Let's look at the solution for better understanding. We are again left out with none other than 1 2 3 4. We begin with the set A and the complement of that being 5 6 7 8 9, since we solved that in the first question. And if I reduce that from the universal set, we are left with 5 6 7 8 9, and we are left with 1 2 3 4, which is the set A itself. Let's look at the last question. B minus C. Set B minus C complement. B minus C, the whole complement. Now, what is set C? What do we have in set C? We have 3, 4, 5 and 6. So let's write that down. 3, 4, 5 and 6. Now if we solve it, let's solve what is B minus C first. As we learned in the earlier chapter, if one set is reduced from the other set, we simply take out all those elements that is present in the first set. We take out those elements which is present in the second set in the first set. Let's look at the example. Let's solve this one for better understanding. In set B, we have 2, 4, 6, 8. In set C we have 3, 4, 5, 6. Now I have to remove those elements from this set. Now I have to remove those elements from the given B set, which is there in C set. Those elements are 4 and 6. If I cross out those two elements, all I'm left is with 2 and 8, which is none other than B minus C, that is 2 and 8. Now, B minus C is just another set, but what we have to find is the complement of B minus C. If we solve B minus C complement, we take out the formula again, universal set minus B minus C. In B minus C, we had only two elements, that was 2 and 8. If we remove that from the universal set, we have the universal set over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I remove 2 and 8 from it, we are left out with 1, 3, 4, 5, 6, 7 and 9. 1, 3, 4, 5, 6, 7, 9 is the answer for last question, B minus C complement. Let's take a look at the solutions. 1, 3, 4, 5, 6, 7 and 9.